Hello, today we're going to talk about electrical cables and fixtures. By fixtures we mean where cables enter junction boxes, receptacles, switches, panel boards, and motor controllers. The safety hazards we have to prepare for are the general safety hazards that are covered with our PPE. At the end of the lesson, we will talk more generally about the electrical safety hazards that we will encounter. Okay, well next we're going to talk about horizontal and vertical cable runs. Above me you can see a good example of a horizontal cable run, and beside me we also have a good example of a vertical cable run. One of the things we have to pay attention to is the supports that hold the cable both horizontally and vertically. There's a different requirement for the number of inches between the cable supports based on whether it's a horizontal or a vertical cable run. I'll let you learn that at reading the reference materials. Also, generally, plastic zip ties aren't allowed, but you'll see that there are quite a few here. This is an old existing vessel, and we have to be judicious in our enforcement of the cable tie, plastic cable tie rule. One thing to pay attention to is the metal banding that holds the cables to the cable supports. A lot of times those are places where chafing can occur in the future. If the cables were bent while they put the metal banding material on, it could be a potential point of chafing later on. Another thing we have to be careful of in cable runs is the radius of the bends in the cable. There's a limit. You can't bend the radiuses too close or you could damage both the insulation or the copper conductors. As a matter of fact, here's a good example of a radius of a cable that is too small and exceeds what's allowed by regulation. Also note the difference between the armored cable and the PVC plastic cable. Plastic PVC covered cable is allowed in machinery spaces, but you also have to be mindful of the smoke and toxicity characteristics of that cable when you purchase it. You know, you have to buy the right cable. One of the things we also have to inspect is where cables make entry into the fixtures, such as junction boxes, lights, switches, receptacles. As you can see, this cable enters this box through a proper cable entry. Up here, you can see that this cable, they only inserted it into the box without any kind of cable entry equipment, and they just used RTV around it to hold it in place. That's generally not very acceptable. Here's an example of a cable entry that was loose. Also, here's a receptacle entry. This was obvious, not new when the vessel was new. This is an addition later on. It's plastic instead of metal, but it does have the proper cable entries into the receptacle box itself as well down here. These cable entries in a Class A machinery space aren't required to be watertight, but if it was up in the weather or out in a rain-exposed environment, they would be required to be. Okay, flexible cords should generally only be used in locations where they feed machinery that may be moving, such as a searchlight or something like that. Even though this isn't a searchlight, a flexible cord is a cord that is made to be moved in a regular way without deteriorating the condition of the insulation. Even though that's a sound-powered phone cord, that's the example of it. They should be used in a limited basis, and you should never use a cord that is designed to be for a flexible installation to actually do normal power runs in a cable way. Also, we wanted to show how cables penetrate watertight bulkheads. What we have here are examples of a lot of cables going through. What we have are steel pieces of pipe welded to the watertight bulkhead with stuffing tubes threaded into them that the cable goes through. You want to maintain the watertight integrity of the bulkhead, therefore they have to be packed right. And part of it, sometimes when you see this putty around it, a lot of times this has A60 characteristics on the specs. So when you see this putty, you can ask the vessel operator to provide the spec data on this putty to make sure that it is proper for the installation, either watertight and or A60 approved putty. Now we'll talk about temporary wiring installations. Generally, when you want to power up a piece of equipment in a machinery space, you should hardwire it into the junction box. You shouldn't make it a temporary installation by using a plug into a receptacle for a piece of machinery that is permanently in the engine room and being used. These should only be for temporarily used equipment, such as drop lights, drills, something else. You would never permanently mount, say, a motor or another operating piece of equipment in a machinery room and then wire it in with a receptacle. It should be permanently wired in. Another thing the inspector needs to be on the lookout for is overloading of receptacles. That's generally done by plugging a power strip into a receptacle and then plugging more things into the power strip. Imagine this receptacle, if I had a power strip plugged in here and here, each with 5 receptacles of its own, and I had 10 things plugged into those two. There are marine safety information bulletins and safety alerts on this issue. Overloading can be dangerous and cause fires, and you should be on the lookout for it. One of the things we have to be mindful of are new electrical installations that are on older existing vessels, such as this light fixture was installed later, and in addition, this receptacle. When you see these newer installations, you have to make sure that they chose the right cable. It has to be marine grade cable and sized properly. When these cables were first installed at new construction, we can assume they were all sized properly for the amount of amps that they were going to be carrying. But as modifications get done, as the ship ages, we have to be careful of that and make sure that that continued to happen. What we have here is a good example of a cable starting to deteriorate. You can see the armor here has started to fail. This brings up a topic that we need to be mindful of when inspecting cables, especially cables that have 110 volt or power running through them. Now this cable goes to a temperature sensor box, so its instrumentation. That's why it was safe for me to grab this cable and move it around like this. If this cable had 110 volts in it, or say 440 volts, and I saw this kind of damage or deterioration, I think you could imagine the dangers of me grabbing it and moving it like that and causing arcs and sparks. So generally, for electrical safety, when it comes to inspecting cables, you have to be mindful of the hazards involved. New, installed, and cable that's in good material condition is generally safe and safe to touch if you're looking at it. But on much older installations like this, where you start having incidents like this happen, you got to be real careful not to make arcs and sparks happen. It's generally best to use your eyeballs first before you touch. When you see an arrangement like this is probably a real good indication of some dead-end cables that have been taped up because they probably would arc and spark if they weren't. You're going to want to get with the vessel rep on these and find out just exactly what we're looking at here. Okay, in summary, for electric cables and fixtures, we've talked today about the safety hazards involved, the supports for vertical and horizontal installations, the radius of bends of the cable, the electrical hazards that can exist. We've talked about the general condition of the outlets, the use of flexible cords, the material condition of the fixtures overall, the condition of the connections and the terminations. We verified the number and type of receptacles, ensured that marine grade cable is used properly. We verified the installation of multi-cable transits and verified that they are the proper type and installed in the proper manner. We also have talked about any tips and unique considerations. I'd like to go into that just a little more. Electrical cables and fixtures is one of the key inspection points on any inspection. The electrical hazards can present personnel dangers as well as make fires. So it's very vital that you do your due diligence on the cables. We talked about how dangerous it could be if you start touching, reaching, grabbing energized cables. We also need to think about what control actions we're going to take when we do find cables that are in such a condition that we have to take action. It's at this point where you're going to want to get with your verifying officer at your unit to make sure that you take the proper actions when you see cables in poor condition.